All right, this is my review of our first unit material from second semester. It's on momentum. The key concepts of momentum are that the momentum is a vector. That's why it has a little line on top. And it's equal to the mass times the velocity. And the units are kilograms, meters per second. That is the momentum. Momentum can be positive or negative. The total momentum of a system is the momentum of all the objects added together. So we can find the total momentum of the system by adding all the momentums together. Please pay attention to negatives. How do we change the momentum? We have to put an impulse on the momentum, or I'm sorry, on the object or the system of objects. Impulse, which is designated by capital I, is equal to the force times the time. How much time did you put a force acting on the object? And if you do a force for a period of time, you will change the momentum. So impulse is equal to force times time, which is also equal to the change in momentum. So if there is no force acting on the system or an object, then the momentum will stay the same. In other words, the momentum is conserved. So the final momentum will equal the initial momentum. So in collisions, for example, if I have a cart, two carts, let's say the velocity initial is 0 and the velocity initial is v naught, and these carts stick together. That's a type of collision that we learned. It's called perfectly inelastic. The momentum initial of the system has to equal the momentum final of the system. So the momentum initial of A plus the momentum initial of B equals the momentum final of object AB, only one object. And just like over here, if I want to know the total momentum, I have to find the momentum initial of each object, add them together, and then I can find the final momentum of each object and add them together. And we can actually calculate the, let's say, velocity or whatever it is the question is. But this is considered conservation of momentum. All right, that's the key material. We had a table of 3 different types of collisions that we learned about: inelastic, perfectly inelastic, and elastic. In all 3 cases, momentum is conserved. The only location that energy is conserved is elastic. Now, this is the exam that we did, and I'll go through these quickly. What is the magnitude of the momentum of a 0.25 kilogram ball? Momentum equals mass times velocity. And so we 0.25 kilograms times 35 meters per second, and that will equal 8.75 kilogram meter second. We have a baseball. It's dropped from rest. It's 3 feet above the ground. So here I am. 3 meters. And here's the ball. The velocity initial is 0. And we're going to hit the ground. And we want to know what is the magnitude of the momentum right before it hits the ground. In other words, momentum equals question mark right before it hits the ground. Well, the definition of momentum is equal to mass times velocity. We know the mass of the ball, but we don't know the velocity at the moment it hits the ground. So we have to use conservation of energy. This is from first semester. The energy, mechanical energy initial equals mechanical energy final. Well, what kind of energy initial does it have? Well, it has potential energy due to gravity initial, which will equal the kinetic energy final located at that location. That's final. Potential energy due to gravity is mgh. That's the height above the 0 line. Kinetic energy final, that's the only energy it has at the final location, because I'm now at the 0 line. And if you plug, mass goes away, by the way, and if you plug in the values of you'll find V final equals the square root of 2gh initial, and you'll find V final to be equal to negative 7.67 meters per second. Don't forget this is plus or minus if you assume down is negative. Now, they asked for the magnitude of the momentum, so I'm assuming that down is negative. So here's my coordinates. Momentum now I can find that is equal to negative 1.38 kilograms meters per second. I use now the mass times the velocity at the location that I'm interested in. All they wanted was the magnitude, so I can drop my negative. All right. I want to know the total momentum of the system. I'll call this object 1, object 2, object 3. So momentum total is equal to momentum 1 plus momentum 2 plus momentum 3. Momentum 1 is, we'll assume, again, they told us that the positive direction is to the right. So momentum 1 is 5 kilograms times 5 meters per second. Plus momentum 2, well, since it's traveling to the left, it's 4 meters per second times its mass, which is 10 kilograms. And then I got to add the momentum of object 3, which is 2 meters per second times 1 kilogram. And if you do that correctly, you will get negative 13 kilograms meters per second. And that is because the object 2 has more momentum than the 1 and 3 combined. Number 4, air tracks move along an air track towards each other. Each A has a mass of 0.53 kilogram, moves towards the right with a speed of 0.75 meters. Cart B has a mass of 0.3 kilograms and moves towards the left. What is the total momentum of the two-cart system? This problem is helping you understand that you must draw a picture and label. To the right, I'll assume is positive. So cart A is moving with a speed of 0.75 meters per second. It has a mass of 0.53 kilograms. Cart B has a velocity of, since it's moving to the left, I got to put a negative sign for that, and mass of B is equal to 0.36 kilograms. They want the total momentum, and it will be momentum of A plus momentum of B. Momentum of A is 0.75 meters per second times 0.53 kilograms plus the momentum of B, this is where people make mistakes, negative 1.28 meters per second because they leave off the negative. One of them has to be negative. So if I assume right is positive, then B's momentum is negative because it has a negative velocity, 0.36 kg. And if I add those up correctly, I get 633 kilograms. Oops. Kilogram meter second. Okay, moving on. A 0.1 kilogram ball traveling horizontally at 15 meters per second strikes a wall and rebounds at 13 meters per second. What is the magnitude of the change in momentum of the ball during the rebound? So the wall actually puts a force on the ball, so it does put an impulse on it. Here is the ball traveling to the right. We'll assume again, right is positive, up is positive. This is traveling at 15 meters per second. It's going to hit a wall, and after it hits the wall, it's going to rebound at a velocity of 13 meters per second, but it's negative 13 meters per second if you assume that the left is negative. So change in momentum is equal to momentum final minus momentum initial, which is equal to, well, the momentum final is its mass, 0.1 kilograms, times its initial or final velocity, negative 13. There's where people make mistakes. And now I got to subtract the initial momentum, 0.1 kilograms, times the velocity of 15 meters per second. And I will get the change in momentum to be negative 2.8, and that is in kilogram meters per second. They only asked for magnitude, so 2.8 would be the answer. If they didn't ask for if they didn't have the word magnitude, it would have to be negative if left was negative. Calculate the impulse, force times time, which equals change in momentum. 4.5 newtons times 1.4 seconds is equal to 6.3 kilogram meter per second. Number 7, we have a ball of mass 0.05 kilograms at rest. Just after being struck, it has a velocity of 89. So someone comes along and hits this ball, velocity initial is 0, and then after that it has some velocity of 89 meters per second. We have a time that they were in contact of 0.75 milliseconds, which I've given you as 0.00075 seconds. What is the average force exerted on the ball by the club? Well, force times time equals change in momentum. This is an impulse problem. I was given the time. This is what I want to know, okay? And that means I must have the ability to calculate change in momentum. Momentum final minus momentum initial, m times v final minus m times v initial. V initial is 0 of the ball. Time we have, force average we want. And so now that I have done that, I can rearrange this equation for the average force. The force equals mass times velocity final over time. Mass is 0.05 kilograms. Velocity final is 89 meters per second. Time is 0.00075 seconds. And if you plug that into your calculator right, it's 5933 newtons or 5900ths to 2 sig figs. I will not take points off for incorrect sig figs. 8, a 2 kilogram mass moving at 6 meters per second collides head on with a 0.1 mass at rest. This is a perfectly inelastic collision. You must know the definition of perfectly inelastic collision. Perfectly inelastic collision is where they stick. So we have A, B, and after they stick together, velocity initial is 6 meters per second. This has a mass of 2 kilograms. This is mass A. This is velocity of 0. Mass B has 1 kilograms. This I'll call mass AB, which is equal to got to add those up. So I got 3 kilograms, and we want to know the velocity afterwards. This is a conservation of momentum problem. There is no external force acting on the system that consists of cart AB. Those are all internal forces that they apply to one another. And I have no outside force, so I can't change the momentum of the system. The initial momentum is the 2 momentums added up. The final momentum is the momentum of the cart AB. Those have to equal one another. So I have 2 times 6 meters per second plus 0 equals 3 kilograms, which is the total mass, times velocity final. Velocity final is 4 meters per second. And that is the answer. Oh, I believe that was the last problem. Oh, I left a page off. Okay, I will insert that in a later video. There was a take-home portion of this test that I did not include. Okay, I hope that helps you. If you have any questions,